Hey, polar bears and polar cubs. Let's talk our second type of reaction, and that is decomp. Now, decomp always starts out in a single compound. It's going to undergo a reaction where it splits into two or more simpler compounds. Now, when it produces these simpler compounds, it does it under heat. So it gets heated up, it gets heated, and then it splits. So AX is always going to be a compound. A can either be an element, and then it would also be X would be an element, or there are some that you have a compound plus then another compound. Okay, so a compound can break into simpler compounds, or it can go from a compound into two elements. Now, the nice thing about decomp is that there are 5 cases. There's only 5 cases, and they follow the same kind of case. So case number 1 is a binary. That means that's 2 elements together. This is AlI3. So this is aluminum iodine. So what happens is it breaks apart into aluminum plus iodine. Now you have to balance. So part of these is states. So the state for binary compounds is always going to go from a solid. It's going to heat up into a solid. And then this actually would split into 2 solids eventually. Okay. In order to balance this, you need to put a 3 here, a 2 here, and then you end up with a 2 here for aluminum. And that is a binary compound. Now, a hydrate. A hydrate is a solid. Okay. And eventually we'll include states. Right now, you guys are just kind of focusing on making sure that you're predicting the products correctly and then balancing them. The nice thing, hydrates will be your favorite because what happens is the multiplication sign just becomes an addition sign. BaCl2 plus 2H2O. Barium chloride is going to be a solid, and water, since it's being heated, becomes a gas. Most people would put a liquid, but it's going to be a gas because it's being heated up. And it's already pre-balanced. That's why hydrates for you guys are your favorite. The third style of decomp is a cation chlorate. Now, why do we say a cation? Because this cation can change. It can change. So really, what you're looking for, it can change. So you're looking for the chlorate. So right now, we're going to do barium chloride. Actually, let's do calcium chloride. This is a solid. Okay. The calcium then becomes the chloride. And I'm only putting the 2 there and the 2 with the parentheses because calcium has a charge of +2. The calcium chloride is going to become a liquid when it's heated, and the O2 becomes a gas. That is a gas. Now we're going to balance it. So you might see that, hey, I have 2 Cls on the left, 1 Ca on the left. That is balanced already. The oxygens is the only thing that needs balanced. I have 6 on the left and 2 on the right. So I need to put a nice 3 here. Again, that is the third type, a cation chlorate. So we've gone through binary, hydrate, and cation chlorate. That leaves 2 left, and they also are the more difficult of the 2. So the last 2 that we're going to talk about are a cation carbonate. Now remember, anytime that you see a cation, this is the part that changes. The carbonate stays. So we're going to use sodium carbonate. That's why it needs the 2, and it becomes sodium oxide. That's also why it needs the 2. So on this one, a carbonate is a solid. If you've ever used sodium carbonate, it's a salt. It could be used in baking. An oxide, we've seen oxides. They are solid. If you remember our empirical lab, the magnesium oxide was a solid. Yes, it was powdery, but it's still a solid. And then carbon dioxide, we all know, would be a gas. 2 NAs on the left, 2 NAs on the right, 3 O's in total on the right, 3 O's on the left, 1 C and 1 C. We're balanced. The last one, again, I cannot reiterate this enough that the cation part of a cation, carbonate, chlorate, or bicarbonate can change. So what does this form? We're going to have sodium, again, as bicarbonate, and then we have sodium carbonate, okay, plus water plus CO2. So sodium bicarbonate, you all have seen at some point in your life. It is sodium, or it is baking soda, and it is a solid. It becomes sodium carbonate, which is also a solid. It produces water vapor and carbon dioxide gas. So if you think about it, sodium bicarbonate breaks up into a salt, water vapor, which is how you get moisture inside of baked goods, and then CO2, which is kind of how you get your bubbles and the fluffiness that you want within the baked goods. How do you balance it? So Na has a 2 here, so we need to put a 2 here. What that ends up doing, okay, is that it ends up making H2 C2O6. Okay, so it makes up that. Now, when you pull out a water, okay, it becomes H2O, subtract that, and you're going to be left with CO4. Can you make C2O4 out of CO2s? You can. We're going to put a nice 2 there. Okay. And those are the 5 types of decomposition reactions. You might be going, Mr. Day, that's a lot. Well, it is a lot, but they follow the same pattern. You just have to make sure that you know the patterns. Okay, practice will help that. States will come, but the states stay the same for every single different type. So if you always have a bicarbonate, it goes from a solid that breaks apart into a solid, a gas, plus another gas. All right. Let me know if you have any questions. You're going to answer questions on our discussion board. And if you have any other questions, please leave them and I will respond.